Preparation of ammonia. We are going to start with laboratory preparation. Laboratory setting. Ammonia gas is prepared by reacting an ammonium salt with a strong alkali. Then the mixture is heated to release what? Ammonia gas. So that is number one point that we need to understand. So you need to react ammonium salt with a strong alkali to release ammonia gas. So the reactants that we have in this laboratory preparation of ammonia, it is ammonium salt and a strong alkali. So we can give an example of ammonium salt, which is ammonium chloride, and a strong alkali, which is calcium hydroxide or sodium hydroxide. So those are the two reactants that we can give as an example. Then now let's look at the word equation and the chemical equation for the production of ammonia in a laboratory. So now we have ammonium chloride plus calcium hydroxide. So we have ammonium chloride plus calcium hydroxide. So we are going to have calcium chloride plus water plus ammonia gas. So this is the word equation. Ammonium chloride plus calcium hydroxide. We are going to have calcium chloride plus water plus ammonia gas. Now let us look at the chemical equation. So we have ammonium chloride plus calcium hydroxide. We are going to have calcium chloride plus water plus ammonia gas. So this is the chemical equation. So balancing the chemical equation, we put a 2 there, we put a 2 there. So this is a balanced chemical equation. So now, when ammonia is produced, the ammonia gas is passed through a quicklime, which is calcium oxide. So calcium oxide, it is a drying agent. So the reason why ammonia gas should be passed through calcium oxide, it is to remove any moisture. So that is point number one. Then ammonia gas, it is corrected by downwards displacement of air. The reason why it is corrected by downward displacement of air, it is because ammonia, it is lighter than air and it is highly soluble in water. So we cannot use water to correct ammonia gas because ammonia, it is highly soluble in water. So that is point number 2. So ammonia gas is passed through quicklime, which is calcium oxide, a drying agent to remove moisture. Then number two, ammonia gas is corrected by downward displacement of air because it is lighter than air and highly soluble in water. So this is the diagram. This is the diagram for the laboratory preparation of ammonia. So this is ammonium chloride plus calcium hydroxide or sodium hydroxide. This is the mixture here. Then when the mixture is heated, ammonia gas, water, and calcium chloride will be produced. So ammonia gas, it will go through the delivery tube. Then, before it is collected here, it will be passed through calcium oxide, which is the drying agent. So what is the purpose of passing ammonia through calcium oxide? It is to remove moisture. And then this type of correction here, it is called the downward displacement of air. So this downward displacement is used because ammonia gas, it is lighter than air. It is less denser. And this process, it is used to test for ammonium compounds. So if we want to test for ammonium compounds, we need to use this method. So number two, industrial preparation of ammonia. So the industrial process used to make ammonia, it is called Haber process. So Haber process, it is an industrial process used to form ammonia from hydrogen and nitrogen. So we use nitrogen and hydrogen to prepare ammonia by Haber process. So that is Haber process. So now the raw materials that are used in the preparation of ammonia in an industry, they are just two. So we need to have nitrogen and hydrogen. So those two are the raw materials. So these raw materials, they are in a ratio. So where there is one nitrogen, there must be three hydrogen atoms. So the ratio is nitrogen to hydrogen. So nitrogen 1, hydrogen 3. So that is a ratio. So now, where is nitrogen obtained? Where is nitrogen coming from? Which is used in the preparation of ammonia. So nitrogen is obtained from air. Remember that 78% of air is occupied by nitrogen. So nitrogen is obtained from air by fractional distillation, or it can be obtained by reacting oxygen from air with a natural gas, where in the air we remove oxygen, then we remain with nitrogen and the other small amounts of what? Gases. So that's how we can obtain nitrogen. So how is nitrogen obtained? It is obtained from air by fractional distillation or by reacting oxygen from air with the natural gas. So this process, it helps to remove oxygen, which has 21% composition in air. So whereby nitrogen, it will remain with other small amounts of gases. Then how do we obtain hydrogen? So hydrogen, which is used in the preparation of ammonia in an industry, it is obtained from natural gas, which is methane. through a process called steam reforming method. That is where hydrogen is obtained, or it is obtained by cracking alkanes from what? From oil, which will give us enough hydrogen. So in case they ask you to say, can you write the chemical equation how hydrogen is obtained, which is used in the preparation of ammonia? So we have natural gas, which is methane, plus steam. So this reaction, it is reversible, where we are going to have carbon monoxide plus hydrogen plus hydrogen gas. So that is a balanced chemical equation. So that is how hydrogen is obtained. The other one is it is obtained by cracking alkanes from oil. So they can also ask you to write the chemical equation here. So we have ethane is cracked down to ethene plus hydrogen gas. So this is how hydrogen is obtained. So there are conditions that are needed in the preparation of ammonia using Haber process. So there are three conditions. Condition number one, we need to have a suitable temperature of about 500 degrees Celsius. And we need to have pressure of 200 atmospheric. Then we also need to have a catalyst. So the catalyst that is used in the preparation of ammonia, it is iron metal. So the iron is one which is used. So condition number one, it is suitable temperature. Number two, it is pressure. Then number three, we need a catalyst. So these are the three conditions that are needed in the preparation of ammonia. So let us now look at the reaction of Haber process. So we have nitrogen plus hydrogen. So this reaction, it is reversible. So we are going to have ammonia gas. That's what we are going to have. So the chemical equation, we have nitrogen gas plus hydrogen gas of the temperature 500 degrees Celsius. Catalyst, we have iron, and we have 200 atmospheric. So the product that we are going to have, it is ammonia gas. So now this is the balanced chemical equation. So that is the equation for the Haber process. So this reaction, it is exothermic reaction. So when we are moving from here, nitrogen plus hydrogen, we are going to have ammonia. The reaction is exothermic. But now when I'm moving from ammonia, giving us hydrogen and nitrogen, it is endothermic. So Haber process, the process of Haber process, it is exothermic reaction. So this is the diagram. This is a plant in the preparation of ammonia using Haber process. So this is nitrogen, this is hydrogen. So when nitrogen and hydrogen enters in this party, nitrogen and hydrogen, they are going to be purified and dried. So all the impurities from nitrogen and hydrogen, they will remain here. The impurities will be removed. So this is the purifier. So nitrogen and hydrogen will be purified. So that is process number one. It is purification and the drying. So once they are dried, they'll enter in this compressor. This is the compressor now. So we have hydrogen and hydrogen will be compressed to 200 atmospheric. Then now we have nitrogen and hydrogen. Then they'll enter into what we call catalytic chamber or catalytic converter. So in this case, we have iron, which is used as a catalyst. So iron, it is used as a catalyst. It is heated to about 450 to 500 degrees Celsius. So now this is where nitrogen and hydrogen will be converted to ammonia. So now you need to understand that not all nitrogen and hydrogen gas from here is converted to ammonia. Only 15% of the mixture is converted to ammonia. So ammonia, it will come in the what? In the condenser. This is the condenser or the cooler. So in this condenser, ammonia, it will be condensed. It will be converted to liquid. Then it will be collected. Now that nitrogen and hydrogen which did not react here, which was not converted to ammonia, it will be given a chance to go back so that it is reacted. So now this, when they ask you to say that, what is this part? This part, it is the unreacted nitrogen and hydrogen recycled. It is recycled. It is going back to be reacted until we have the maximum production of what? Ammonia. So this is the diagram. So remember that only 15% of the mixture is converted to ammonia. And the mixture is cooled until the ammonia condenses to liquid. So this is the procedure. So the two gases are mixed and cleaned, which is purified to remove impurities. Then the mixture is compressed until it reaches 200 atmospheric pressure. Then the compressed gas flows to the converter with beds of hot iron at 450 to 500 degrees Celsius. So only 15% of the mixture is converted to ammonia. So the mixture is cooled until the ammonia condenses to liquid. So the nitrogen and hydrogen are recycled to the converter for another chance to react. So we go now to the properties of ammonia. So number one property of ammonia is that ammonia, it is a colorless gas. Number two, ammonia, it has a pungent smell. Number three, ammonia, it is lighter than air. Then number four, it is highly soluble in water. Then ammonia, it is easily liquefied by what? Cooling. It can be easily converted to a liquid. So the solution of ammonia is alkaline, meaning ammonia, it turns a red litmus paper blue. Then ammonia, it reacts with hydrogen chloride gas to form a white smoke, which is ammonium chloride. Then ammonia, it reacts with acids to form salts. So uses of ammonia. Number one, ammonia, it is used to make fertilizer. Number two, ammonia, it is used to make nitric acid. Then number 3, ammonia, it is used to make explosives. Then number 4, ammonia, it is used to make cleaners. So, test for ammonia gas, it has a pungent smell. It turns a damp red litmus paper blue.